Today we will look at another part of statistics, which will look at grouped frequency distributions. We're going to look at the measures of central tendency and dispersion when we're dealing with group data. Now, group data is simply data that is arranged in terms of class intervals. So how do we calculate the mean for group data? Is almost the same as how we calculate the mean for ungroup data, except that for group data, we are going to bring in the concept of a frequency. So an F is what will make the slight difference, which is going to be significant. So this is the difference in the formulas. So now we need to understand how to come up with what we call the distribution table. So for instance, we're given the scores here and their frequencies. So the first thing is you need to come up with the midpoint. The midpoint is simply adding the lower bound and the upper bound, then dividing by 2. So how did we find this 81.5? We added the 80, 280 plus 283, then we divided by 2 to get to 81.5. So we do the same for all the classes we have here. So this is how we find the midpoints. Is that clear? From the midpoint, we're also able to establish our class width by identifying the difference between this and that. We discover that it is the same difference from here to there, which is 4. So our height, our class width is 4, but I don't need that for now. We just need to understand how to get the mean. So the mean will simply be by multiplying the midpoint and the frequency, midpoint and frequency, then we divide by the total sum of the frequencies. So our total sum of the frequency is denoted by n. So 2 times 281.5 plus the next one is 8 times 285.5. And we go on until the last figure we have is 2 times 301.5. So we also add the frequencies 2, 8, 14 up to 2. So this is how we do the summations. Are we together so far?
Yes.
Okay, so after we do, then we get our mean, which is 291.1. So this is how we find our mean for group data. So let's proceed. We now proceed to looking at another sample data. Here we're told that we have employees at the company who are arranged according to their ages. So the same way, lower bound plus upper bound divided by 2. So this is 44 divided by 2, it's 22. 25 plus 29 divided by 2, we get 26. So discover that the height here is 5, which is the same distance from here to here, which is 5. Our frequencies is given by the number of employees. So to find our mean, we just multiply x, f. So 22 times 8, 27 times 37. Then the total we get here, we divide it by the total frequency. So this is what we get here as 34.5. That is our mean age that we're going to approximate. So this goes on and on. If you have this and is 3 and 4, we add them, divide by 2, we're going to get the midpoints. We do the same until 13 plus 14, divide by 2, we get 13.5. And the frequencies, we have them as they are showing here. So after we multiply each of these ones, we divide by the sum of the frequencies, which is going to be called n. So when we divide by that, we're going to get 8.33. That is our mean. So in the case that we have, sometimes we use the word under. So 3.5 and under 3.2. It's the same thing, just add the 2, divide by 2. So these are the midpoints that we're going to have. The frequencies, keep them as they are. We multiply these two and divide by the sum of the frequencies. So we get our mean. So this is how we handle the mean for group data. So now I want to look at the other measures of central tendency. So we may be given some data as follows. This data shows our list of balances on a credit card for a 5-month period. So we're asked to calculate the range. The range is simply the difference between the highest number and the lowest number. The range is always a positive value. So the difference between 2 points, whether they're on the negatives, we always get a positive value. So the highest number in this case is 1075. The lowest value is what? 485. So the difference is our 590 between the two values. So you can't get a negative range. So here we also have figures. So we're being asked to calculate our range. The highest figure is what? 70, 75. The lowest figure is what? 485. So the difference here is 6590. That is the range. This is one of the easiest measures of what? Central tendency or dispersion. You can also bring in negatives if you want. The highest number is 32, the lowest number is negative 10. So the difference between them, minus and minus, will add. So we're going to get 42 as our range. So regardless, if all of them were negatives, we can't get a positive. So the highest number on the negative is a smaller numerical value. So 2 is the highest number. The biggest number is the smallest number. In this case, 25. So 2 minus negative 25 will give you a positive 23. So this is how we find the range. All right. You may also be given information in this table in terms of years. So they ask you to find the range for a town Dallas, a town Chicago. Same rule, the highest figure, subtract the lowest figure. Same rule, highest figure, identify it here. Score 27, the smallest figure, 231. Get the difference between the two. So this is what we call a range. Now you need to also understand that if the range is smaller, what does it mean? If the range is wider, what does it mean? So if you have a wider range of values, just know that the levels of accuracy of that sample data is a little bit inaccurate. So the bigger the range, the more inaccurate you are in terms of giving a premise. All right. So the range of these temperatures is highest number minus the smallest number. In this case, we're going to have 11 because we're going to add using BODMAS. So here we've been asked to find or identify the most and the least consistent gophers in the group using just the range. So let's go to sum. Sum, the highest number was what? 105. The lowest number was 98. For Debbie, the highest number was 96. The lowest number was 79. So the difference is 17. Then finally, Jeff, the highest number was 95. The smallest number was 81. So we can tell here that our data gives the ranges for 3 different people. So we can see that Sam here is the most consistent gopher because he has the smallest range of the 3. Debbie is the least inconsistent, is the most inconsistent gopher because he has the widest range. So we can see in this data set that we've been given that sum is consistent, but from the reading, you can see that sum is the worst gopher of the three, but that has nothing to do with consistency. So you can see here in terms of the scores. Okay, for consistency, showing in terms of uniformity. All right. So we could have now what is called the interquartile range. So we have the range of the figures. Now, how do you find the interquartile range? It is a difference of the percentiles. So interquartiles are simply percentiles. So we need to find what we call the first percentile, which is the 25th, it's 25 over 100. Over 100. The second percentile is simply 50 over 100, which is half. And the third percentile, that is 75th percentile, which is 75 over 100, which is same as 3/4. So I want to find the interquartile range. We've been given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 figures. So let's find the first quartile. First quartile is simply a quarter of what? N. Or N is what? 10. What is a quarter of 10? 2.5. 2.5 always get the next integer, which is what? The third integer. Remember from our previous class? So we're going to get the third position. So third position after rearranging them, 1, 2, 3. So 87 is our what? Our first quarter. The second quarter is actually our median. It is simply half of n. So half of n is what? 5. So whenever we get a whole number, we have a problem. We get that number and the following number. So the fifth and the 60th number, we average them. So we're going to get the fifth position and the 60th position, we average them. So here of 1, 2, 3, 4, 5, and 6. So 94 and 95. So 94 and 105, 102, we average them. So meaning our median is 98 patients. When we go to the third quarter, it's simply 3/4 of n. 3/4 of n is 7.5, which will round up to the 8th position. 8th position, 1, 2, 3, 4, 5, 6, 7, 8 is 109. Are we together so far? Are you catching up from the previous class we had?
Yes, I just have a question on the P. The P is the
We said
okay, like in this case, of course, I understand that the quartiles they are specific. In the previous class, if we're not asked, if we're not told what percentile we're finding, the P can do you use the position of the number as P and then N as N I understand, but the P.
you'll be given sometimes the 65th percentile, they will be given it stands for percentile. So the third
There's a question I was going through in the tutorials. I think it's just the first one. It didn't have it didn't have the percentile, but you're asked to find the percentile. So I was a little bit. But anyway, I'll go through the video so that I should understand. Maybe in the video, because we did those questions.
the percentile is this. All right.
Okay.
Okay, so after finding these, we now can summarize Q1, Q2, and Q3. Okay, so our Q1 we found as what? 87. Our Q2 we found as what? 98. And our Q3 found us 109. So the difference between Q3 and Q1 is called the interquartile range. So 109 and I said 7, so we have 22 patients. Are we together?
Yes.
And half of the interquartile range is 11. It's called the semi-quartile range. So we now go to our so we can calculate the interquartile range also using what is called the median method, where we're going to compare our interquartile range. So here we've been given figures as follows. So clearly we can tell from here that the middle number is 87, numbers aside and 2 numbers outside. Right? So now we want to see how to compute the quartiles using this analog method. So from here, our middle number is what? 109. You can see that there are 2 figures there and 2 figures there. So the median method will help you identify the quartiles, given only the median. So you don't even require you to use any index point. So our median was what? 98. So when you go to this data, our median was 98. Our second quartile, what was our second quartile? Q2, 98 patients, which was between these two here, 98. Also on by the averaging these two. Okay, so when we get 1, 2, 3, 4, 5, these figures here, 75 up to 94, we identify the middle of these numbers inside. So this becomes our lower quartile. Then when you go to this other half, the numbers inside, starting from 102 to 120, the middle number here is what? 109. So this is 109. Then the difference between these two is what we call our interquartile range. So 109 minus 87, which is still 22. Okay, so let's see how to find the interquartile range when we're given our sample, which is odd, like 9. So we have a sample of 9, and these are the figures there. So firstly, you identify the lower quartile, which is a quarter of 9. So a quarter of 9 is 2.25. So what do we do to the 2.25? We round up. We get what?
Round it up.
The third integer. What is the third integer? 1, 2, 3. This is 3 what? 51. Are we together?
Yes.
Then how do you find the upper quartile? Q3? 3/4 of 9.
9.
So what is 3/4 of 9? 3/4 of 9 is 6.75. We round up to get the 7th position.
7th position.
1, 2, 3, 4, 5, 6, 7. So as long as it has a decimal point, whether it is 1, 2, 3, we round up. But if it's an exact figure, like 4, 5, we get the 4th number and the 5th number divided by 2. You remember, right? So here, the 7th position. All right. So the 7th position is 498. This is 498. And here we're at 351. So we get the difference between these two. That is 147. That is our interquartile range. Half of this is the semi-quartile range. So using the other pointer, we can now identify from the median. How do you find the median? The median is what? Half of n. What is our n? 9. Half of 9? 4.5. 4.5, the 5th number. 1, 2, 3, 4, 5. This is our median. So the numbers before this one, 1, 2, Okay, 1, 2, 3, 4, 5. And here we have 1, 2, 3, 4, 5. So the middle number from here is this one. The middle number from here is that one. So these ones also can use to identify our median. So this is how median is identified. Okay. So let's go to data that is a lot. For instance, we have 2007 and 2008 monthly data for crude oil. And in this case, we're being asked to use a median to calculate the interquartile range and also to see which year was more consistent. So we can also use a range for the quartiles to see the consistency. So we're going to find the lower quartile, 1, 2, 3, 4, 5, 6, 7. So I have 7 here. So how do you find the lower quartile? A quarter of 7. What is a quarter of 7? Point 0.25 times 7. Quarter of 7. Half of 7. And 3/4 of 7. So a quarter of 7 is 1.75, which is the second position. Here, half of 7 is 3.5. So we get the fourth number. 1, 2, 3, 4. Fourth number is quarter. And 0.75 of 7 is 5.25. Get the sixth number. 1, 1, 2, 3, 4, 5, 6. So this is Q1, Q2, and Q3. Q1, Q2, and Q3. So to find the 2007 interquartile range, we subtract 59.25 minus 51.36, which is this figure. For 2008, 126.16 minus 186.64, we find this figure there. So we can see the one with a smaller range is 2007. So we can say this one was more consistent. So interquartile range is vital because it also gives us a picture of consistency. Okay, it gives us a picture of consistency. So are we together? Any questions this far?
No.
Okay, so now we continue. So now we have information to say that the range, the smaller, the more consistent. So even here, we find the interquartile range. But when in the quartile range, you get the difference between the highest quartile and the smaller one. Now I want us to learn how to come up with the outlier, and finally, how to come up with the stem and leaf diagram. So data here has given us information of 15 households. These households are waiting on the market to be sold. So we want to calculate our interquartile range and also identify the outliers. So outlier, we come up with what is called a box whisker plot, which will give us an out of range figure. So the first thing is we find the quartiles. So how many houses do we have? There are 15. So we have a quarter of 15, which is what? 3.75, which we round off to the fourth number. So we count 1, 2, 3, 4. So this is Q1. Then Q2 is half of 15. Half of 15 is what? 7.5. So round off to the eighth number. So 1, 2, 3, 4, 5, 6, 7, 8. This is the second quarter. And third quarter is 3/4 of 15. What is the 3/4 of 15? 0.75 times 15, which is what? 11.25 is the 12th number. 8, 9, 10, 11, 12. So this is the third quarter. So far, we're together. So after finding the quartiles, we now allow for these quartiles that we've calculated to give us our interquartile range. Now, these quartiles here, we have quartile 3 and quartile 1. So to find our interquartile range, we're going to subtract third quartile minus the first quartile. So which is 64 minus 36. All right, which is 36. So our 36 is called our interquartile range. So we found this and rounded off to 12, and we found the position of our third quartile 64. The first quartile we found as 36. So we get the difference between 36 and 64, which is 28. 28 days. So if you are going to bring in this figure that we are looking at, so we have three things we found: quartile 1, quartile 2, and quartile 3. Quartile 1 is 36. Quartile 3 is 64. Okay. Then quartile 2 is 50. Then the interquartile range, the difference between these two, 28. Then we have a correction term, which is simply a scalar quantity. Just multiply the interquartile range by 15, by 1.5. So multiply 1.5 times 28. It's a general figure, which is 42. By the way, the lowest values we had was 9, and the highest value we had was 115. So here you put your 9, and here you put your 115. So this 42 is helpful because you need to add it to this 64 and subtract it from this 36, the figures that are going to be outside that range are called outliers. So here, this is the 40 we're talking about, which is the correction term. So 36 minus 40, we get -6. So -6 is somewhere there. So meaning this 9 is qualified, it's inside, it can't be an outlier. Then 1.5, you multiply it again to the 28, which is the 40. All right, 42, which is the 42. So the 42, we now add it to the what? The upper quartile, which is the 64. So 64, we add the 42 to give us 106. 106 somewhere here. What happened to 116? 115 is outside, it's an outlier. If there are any numbers that are more than 106, we can check here, they become outliers. The next nearest number is 94, which is within. So we can say 115 is an outlier because it is a data set that falls outside the lower and the upper limit. So these are the limits we're talking about. The upper limit is 106. The lower limit is -6. Same here, we're being asked to identify whether there are any outliers. So this information is arranged in order. So the first thing is to find the quartiles. How many are these figures here? We're told that there are 13. So we find the first quartile, which is quarter of 13. What is a quarter of 13? So 0.25 times 13, giving us 3.25. Are you together so far? 3.25. What happens to the 3.25? We round up to the fourth number. 1, 2, 3, 4. All right. The upper quartile, the median is half of 13. So half of 13 is what? 6.5. Round off, which is the 7th. 1, 2, 3, 4, 5, 6, 7. The second quartile. 1, 2. Then finally, Q3 is 3/4 of what? 13. So 0.75 times 13. What do we get? 9.75 is the 10th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here. This is the third. All right. So we have the quartiles. So now what we do, we find the difference between the upper quartile and the lower quartile. So 12.5 minus 9.6. All right, will give us our interquartile range. So once we get those two different figures, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes. Any questions so far? Before we proceed. Do we have any questions so far? Okay, so we find our difference between the two, the upper quartile and the lower quartile. Now, 1.5 is our correction term. So the 1.5, we multiply it with the interquartile range you found. 1.5 multiplied by the interquartile range which you found. So we call this a correction term if you want. So we have 1.5 times 3.45, which is 5.175. So 5.175, to this we subtract, to this we add. So we're going to have the extreme values, which are 4.125 and 17.925. So in this case, we need to identify which numbers are outside these two. So from here, we discover that 17 is above that and 4 is below that. So there's no outlier, meaning all of them are within. We have no outlier. All right. Similarly, we use the same concept here. Identify any outliers. So this is where we apply or use this box whisker plot. So the box whisker plot is very vital because it helps you illustrate what we've been doing, the findings there. All right, so here we have about 11 period, which shows children who attend after school programs. So these are 11. So we're going to use a box whisker plot to illustrate the data. So we find the first quarter, a quarter of 11 is 2.75, meaning the third figure, 1, 2, 3, which is 29. Then 3/4 of 11, which is 8.25. We get our upper round off, which is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 70. So we subtract the 270 minus 29, which is 41. This 41, to get the correction term, we multiply by 1.5. It's quicker and easier like that. So 41 times 1.5, which is 61.5. 61.5. So 61.5, we now add it to the upper and subtract it from the lower. So here to the 70, we are going to add the 61.5, which is 130.1.5. To the 29, we subtract 61.5, we get negative 32.5. So to draw the box whisker plot, you can use a number line. Our highest figure was 92. Again, 92 is somewhere there, and our lowest figure was 20. So 20 is there. You draw your box. The lower Q1 was 29, the higher was 70. So 29 and 70. The median, half of 11 was 5.5, which is the sixth number, 1, 2, 3, 4, 5, 6. So 56 was the median, which is here. Just number line, just reflecting that. Now, this is how the box whisker plot is supposed to be drawn. All right. This is how the box whisker plot is supposed to be drawn. Now, we can also tell or describe the skewness, whether it is left or skewed to the right, depending on the information. So skewness just tells you how much the distribution is bending. If it's a right skewed data, most of the data will be tilting to the right. If it's a left skewed data, most of the data will be skewed to the left. If it's normal distribution, 50-50, meaning your skewness is 0. This is a right skewed data. So with information that we had earlier on, we have how many? We have about a 15-chapter book. So we want to draw a box whisker plot using this data. So remember, 15, a quarter of 15 is 3.75. So the fourth number, 1, 2, 3, 4. Then 3/4 of 15, 11.25. So we go to the 12th. And the last number, we did this question there. So 13, 15, and 26. So the difference between 26 and 13 will get the interquartile range, which is 13. This is 13 multiplied by 1.5 to get our correction term, which is 19.5. So 19.5, we add it to the 26, we get 45.5. We subtract it from the 13, we get negative 6.5. So when you draw the box whisker plot, our lowest number was 9, the highest number was what? 36. The box we have 15 as a median, 13 as lower quartile, and 26 as upper quartile. So when we add our 19.5, here we get negative 6.5 on the lower bound. Negative 6.5 is somewhere here in the negative. Then when we add it to the upper bound, we get 45.5. 45.5 is somewhere here. But from the distribution, we discover that we have a number which is outside the limit, which is 49. For 49 here, we can use and asterisk to indicate that the outlier is outside the box. So this 40 will indicate that it is an outlier, hence we have the illustration there. We can also describe the distribution here, whether it is skewed to the left or skewed to the right. So we first find the mean by adding all the figures and dividing by the number of elements. So we 9 up to 49. So we remove the 49 because it's an outlier. So we find the mean for the 14 elements. Divide by 14, so the mean is 20. So because 20 is greater than 15, which was a median. Our median is as follows. The second quartile. Whenever the mean is greater than median, we say that this is a skew to the right. Whenever the mean is less than the median, we say it's skewed to the left. So our mean is 20. However, our median was what? 15. So whenever this is greater, we say it's skewed to the right, or it's positively skewed. That is one way. The other way is, you see the gap here. There's a gap on the left and the gap on the right. When the gap on the right is big, we say it's skewed to the right. If the box was like this, and this is your left and this is your right, you can see the box that here is bigger, I would have said it's skewed to the left. Are we together? Are we following? Are we following? All right. So we also have a data set that has distances of car drives in miles for 15 fill-ups of gas stations. So we want to draw a box whisker plot using a 5-number summary. So this data is already arranged in order. So 15, so half of 15 is what? 7.5. So the 8th number is a median. So a quarter of 15 is 3.75. So the fourth number, 1, 2, 3, 4. So we've already memorized these ones. If you have a 15, these ones are the figures there. So we identify our lower quartile is what? 239. The upper quartile is 279. The median is 255 here. The lower value is 250 and 285. 215 and 285. So when you sketch this here, you can tell that this is skewed to the right because it's bigger here. Of course, you can multiply our 1.5 on the interquartile range. So the interquartile range is the difference between 279 and 239. So the difference between the two, you multiply by 1.5. So you discover that in this case, maybe we don't have an outlier, but the distribution here tells you that it is skewed to the right. You can tell this. Also, you can also use all the figures, find the mean and compare them to this figure. If its mean is more, you can say it's skewed to the right. So mean in this case was 255.2, which is almost asymmetric. It's almost close. However, it is skewed to the right. It's almost asymmetrical. All right. So whenever the mean is equal to the median, we say it is asymmetrical. So let's go to another important stem and leaf flower. So this flower, it helps you give a structure or the distribution of how the data will look like if you separate them by stem and the leaf. So we have numbers as follows, which we want to divide or illustrate using stem and leaf diagram. So identify the numbers that are resounding. We call them the what? Stem. And the leaf are the last figures that we have. So we have numbers starting with 2s, numbers starting with 3s, numbers starting with 4s. So for the 2s, 28, 3s, we have 34. So the 3 is already there, so yeah, 3, 4. The 4s, we have 42, so 42. Another 47, so since there's a 4 there, 47. And the last number is 49, so 49. So this is how we draw the stem and leaf diagram: 28, 34, 42, 49, 7. So we can also do the same on this data here to draw the stem and leaf diagram. The smallest number starts with the 1. Then we have numbers that start with 2s, 3s, 4s, and 5s. So 1, say we have 11, so 1, 1, 12, 1, 2, 14, 1, 4, 17, 1, 7. For the 2s, we have 2, 0, 2, 0, 2, 2, 2, 5, 2, 5, 2, 6, until the last number 2, 8. The 3s, we have 3, 0, up to 39. So 39 is there, you put them on that. The 4s, we have the smallest as 41 up to 49. So 41 up to 49, these are there. And the 5s are 50 and 56. So this is our stem and leaf diagram. What if we had numbers like 102, 103, 104? So these ones are your stem. So we have 10 there. The last number is the leaf, and 4 there. So 111. So 11. So the order just moves like that. Sometimes we may move from backwards here. So we've been asked to identify the values in here, which, of course, let me go back to here, 30 cities. So you can be asked to find the first quarter, second quarter, third quarter. So a quarter of 30.25 times 30 is what? 7.5, which is the 8th number. So 8th number is a first quarter. So we count 1, 2, 3, 4, 5, 6, 7, 8. So this is our first quarter, which is 25. Then the median is 0.5 times 30, which is 15. So 15 is giving us what? The 15th number and the 16th number. So we start count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So these two numbers here. So 32 and 34. So the median will be 33. If you average same. All right. Then the upper quartile, which will be the upper quartile, which will be 0.75 times what? Times 30. It's giving us 20.5, which is the 22.5, which is 23 now, because it's in 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 41, so it's 41. So you can see how that this is able to give you a summary of how the data must be. So here we've been given already a done stem and leaf diagram. So we're asked that you identify the values represented by the stem and leaf diagram, which leads to the new number of cars sold at the dealership over the last 20 months. Assume 219 2/9 is 29. So these numbers, we can list them. So this is 8, 9, 9. This is, for the tens is nothing. 20 is of 20, 21. Just listing them the way we are doing it, moving backwards. So this is exactly from there. All right. Then you're given this and you're asked, in this case, to identify the mode. You use this one. The last number is your what? Your leaf. So 16 and 3. 16, 3. 16, 3, then another 3. You go there up to 26, 5. So 26, 5. So to identify the mode is a number that is resounding. So 3s that are consecutive here. 333. Okay, we have another one which is more resounding, which is quadro 6. So quadro 6. So 6 is not the mode, but 206 is actually our mode. So our mode here is 206. So you can tell from the stem and leaf diagram. So here we are asked to come up with a stem and leaf diagram. Okay. So in this case, our figures will need to be rounded up to the nearest integer because we don't deal with decimals. So round them up to the nearest integer decimal. So this will be 73. Say 10, 105, 103. Just round them up. Okay. To the nearest whole number. Sorry. So this is 74, which is there. This is 117, 104, 102, 98. So in this case, don't round up, but use a normal way of rounding off. This is 96. So we redo the whole because of the data we're dealing with here. We're looking at the ratings of a quarterback at the NFL. So after rounding them, then now we can use this stem and leaf diagram. So the smallest number is 70, and the highest number is 117. Remember, the last number is what gives you the leaf. So when you have something like that, then you'll be asked to calculate. What are you being asked? Construct stem and leaf diagram such that the stem present tens and possible unique values. So this is a stem and leaf diagram, that's all. But if you're asked to find the mode will be this triple one. We have anything that is triple. So our 71 would be our mode. So stem and leaf diagram is very important because it helps you simplify your data. So I'll end here for today. We've learned quite a lot. We will send you homework based on what we have done. In fact, I already sent homework. Just check the questions that I sent you. So we end here unless any questions.